so pressure when I open the valve. And we're spiking up to like 9 on this gauge. But this is probably more accurate. Gauges are less accurate at the extremes. They're more accurate in the middle of the range. So this getting up to 12 is probably not right. It's probably more like 9. Yeah. And yeah, so did you see it bounce? And then it settles down again at like 1/3 of a PSI. So that the water is slamming into the valve, it's reverberating back up the hose, and then coming again. It's, you know, just like a hammer does on an anvil. Bing, 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 bing. It's doing the same thing in the hose. 9, and then like 2, and then almost 1. And then it settles back to our water column pressure. So this alone demonstrates that it is able to generate far more pressure than just the height of the water column itself. In other words, gravity is only able to generate 0.3 psi here, but with the dynamic system, the water hammer, you can get up to 9 psi. Now, obviously, I wouldn't be able to pump all the water to that height. I would be using the energy of the water to pump a smaller amount of water up to that height. So now I have the gauge here, and this is the high pressure output when we slam this valve. Now it goes to a dead end, but I'm going to try to time it right so that I can maintain the pressure on the gauge if I can. Probably take me a few tries. So this valve's open. So when I close this valve, the pressure is going to spike into here. And then if I close this valve at the right time, the pressure will maintain on the gauge. There. Actually got that first try. So there, we've got 9 psi held right here, produced by this system just by closing this valve and then closing this valve at the right time. So what would be really nice is if they had a valve that would only allow water to flow one way. Now, of course, y'all know they do. It's called a check valve. And this is a check valve. They're really simple. You can see the arrow. And all there is in there is basically a seal. There's a rubber washer and a brass plate that goes all the way across the opening, and a spring. So the spring is always pushing it this way. And what happens is if there's more pressure on this side, it will overcome the spring pressure and water will flow. But as soon as there becomes more pressure on this side than over here, the water is going to push everything back with the spring and push the brass plate against the rubber washer and seal it up. So basically, if the pressure's higher here, water will flow. If the pressure's lower here, the valve will close. And that works automatically. So I took this check valve apart to really see how it works, and there's a lot of different types. But here you can see the brass plate with the rubber seal, and down inside here, there is a face that seals against. And this sits in there in that position, and that's what happens when the valve opens and closes. It's just moving back and forth there. So let me put that in. I'll replace this with this. If I give an outflow here, and we do our water hammer, we get our 9 psi, but then it drops back down because I'm letting it come out. So let's close that off. So you might think, 9 psi is great. It's not that much. 10 feet of head is about 4.5 psi, so 9 would be enough to pump 20 feet high.